The first one is Doc Bishop with smelted aluminum and brass.
Hi, everyone. I have never done this before, so we're going to try to figure it out as we go along. But I got a short video to show you real quick. If I can. That's the foundry that I have. And what's inside that is started off to be keys. Now, the keys look like this. I'm going to start passing around if you all want to play with one.
Is that foundry a recycled propane tank? Is that
No, this is started off, I bought this one.
Oh.
It is, can be made out of recycled propane tanks, can be made out of anything as long as you can get the temperature a little over 1,500, 2,000 degrees is what we're looking at for the temperature on that. Now, for the pouring of it is the most fun. Liquid keys. But keys wasn't fun enough. I also do aluminum. Soda cans. And I had a lot of fun playing with them. So I did want to share because I had a lot of fun playing with them. I do have my foundry here. It is in the forge. And I am going to be playing with it again. Next time I fire it up, I will go ahead and put it on the, what is that platform we have? Mattermost, if anybody wants to come and play as well and see how it's done in real time.
So these are like blanks for blacksmithing?
Yes and no, it's a softer metal. It's not the steel for blacksmithing, which most blacksmiths are going to use steel. Blacksmiths classify this as trash metal.
What would you do with these?
Decoration, casting, so what I've actually already done with the keys is I'm starting to work on fixing a lock at the Blunt Mansion. Because we can't replace them, we've got to repair them. So I've got a broken piece inside the front lock that I'm going to try to recast the entire piece unbroken out of brass or recycled keys.
What do you make for the casting?
Green sand at the moment. I can do green sand at the moment. That's what I plan to start with. But essentially, you can also use styrofoam. So anything you can carve out of styrofoam, the styrofoam will heat and evaporate and melt as the metal's taking the place of the styrofoam. So you can take a styrofoam piece, carve, just like a lost wax, but you can do the same thing with wax. Or steel. So if you have a steel mold, the steel's a hotter temperature than the aluminum and the brass. So you can actually do a negative mold in steel and pour directly into a steel mold. Haven't gotten that far yet. I'm just getting my materials together now.
We're going to be following you.
Oh, once I cast something, I'm gonna be right back up here. Yes.
For small jewelry pieces, you can use cuttlefish.
Really?
Yeah.
I did not know that. Thank you.
And you can just like press into them and make the glue and pour it in.
Oh, that would be cool.
They're used for silver pewter and stuff.
The same basic melting temperatures, yeah.
What was that, what material?
Cuttlefish bone. You can use that as your mold. You can like compress things in it, cut out the moon and just pour it and wrap it around and just pour it in.
Any other questions? No? Well then, next.
All right. Next up, we got Rick Slover with vehicle decals. Yeah. Another first timer here. I got started in this little project when my wife got her amateur radio license, and I decided we need matching decals for our cars. So instead of going out and buying them and spending lots of money, I decided we're makers, we can make it. So that's what I'm trying to do. And I'll show you the process we did. Very, very simple, really. All you need is some vinyl matte paper. This is available on Amazon, anywhere you can buy them at the the different office supply stores, but it's perfect for making vinyl decals you can place on your car. And you need some self-adhesive laminating sheets. These are peel and stick self-adhesives. One issue you have with decals going on cars is they're very susceptible to the ultraviolet rays of the sun, and they'll fade away, whatever. To fix that, you use UV resistant coating that you spray on the decals in order to fix them, to keep them from turning in the sun. And so basically from that, I should pass around this one that we did, just playing around. This is one of the decals we did. The back of the label is peel and stick. You just stick it on your car, no big deal. This particular laminate material, let me show you that, has a peel off backing, and basically once you get your vinyl decal printed with your laser or with your regular inkjet printer, which is what I use, then you make sure you fix it with the fixer, and usually just several coats of the spray, very light coats, but do 2 or 3 coats just to make sure it's covered well. And then after it dries, then you apply the laminate to that. It's not a big deal. From that, I got my call and her call. So that's for our cars. Oh, thank you. Come over here. That's me. That's her. Whoops.
Did you do that with a laser print?
Inkjet. Yeah. Yeah, it worked good. I was surprised it actually didn't run or anything. It worked good. Any questions? Again, that's my first one. I have another project coming up that I haven't really started yet, but it's in the works, and that's an enclosure for a 3D printer. So I'll be hopefully sharing that with everybody in the near future. Thank you.
Can't leave you without your UV protection.
Yeah, that.
That's pretty good on
Yeah. That spray's a good idea. I know people have made a few with the vinyl cutter, and those fade too. I bet that would help with that too. Next up is Tracy's going to show a trophy.
This was a project for work, actually. I work for Acreworks, and we're fiber arts. We make bobbins and stuff for fiber arts. And we participate in a community fiber thing every year where it's called Tour de Fleece. So it's like Tour de France. So this year I got to design the trophy for it. And it's always bike themed. So this is 3D printed. And the base is made of beech, which I'm usually the woodworker, so I made the base too, but this time I got to do the trophy, which the wheels are designed after our bobbin whorls, one of our bobbin whorls, and the way I designed it, I don't have experience with the fancy 3D program that Aiden uses for all of our other stuff. So I used an Inkscape plugin where you can just draw the thing in Inkscape and then import it into OpenSCAD, and it'll make it into a 3D model. And that's really how I prefer to do all my 3D printing now, is just you can draw it in 2D and make it turn into 3D automatically. So this was the trophy I designed. It's a nice little bike. Oh yes, under the... They are hedgehogs. They're our mascot, and I do not know why. They were there before I was, so.
Thank you. Next up, we got Bob, who's going to show us a table and coffee.
Okay. Well, I bought a slab of wood to make a coffee table, right? That was the easy part. The first thing I had to do was to get both sides parallel. So I made a jig for the router and stabilized the thing on the garage floor, and then took the router and changed the dimension, depth a little bit, and went across until I had the whole thing even on that side. Turn it over, and now do the same thing on the other side, so I now have two parallel faces. So then I took the thing in the house, and I said, honey, how does this look? And she said, I love the top. The base needs some work. So I started designing a base. And I thought, I think it'd be really cool to have 5 legs with a little curly Q at the end, right? And I'll make it out of 1/2-inch steel. So I did, and fortunately, Flexo was finally available and built and there. So I bent the steel, and then I 3D printed the support so that I could see what the heck the thing looked like standing up, but it's not attached. Then I welded it all together, and so that's what it looks like freestanding. And there's the coffee table in the living room. And it got much higher marks this time. Yeah.
Did you hand forge the legs or have them?
1/2-inch round rod, and I just put it on the bender out there in the cold. Yeah, just used Flexo, and yeah, fortunately the arm is long enough to be able to. Other.
Did you zoom in on the table in your last picture in the living room? You can see
Oh, this is one kind of cool picture here, though, too, I want to show. That. Well, shoot. There. One of the things that I was worried about is scratching the floor. And so it's like, well, I could weld some kind of a flat pad on there, but given the curve and everything else, it's actually upside down. Maybe that'll help. And I was concerned. I didn't really want to weld anything. And then one day I got this idea. I said, why don't I 3D print it? And so I set up just a cylinder, and I use OpenSCAD, or OpenSCAD, as I found out it's really called. And then I took and subtracted the curve. It's really cool, and that clip just nestles right into the right spot on the rod. So it was just a fun thing. Now let's see if we can find this. So the wood is finished. Yeah, that was a bit of a disappointment. I put tons of coats. I thought enough coats of epoxy resin on there, and got the bubbles and filled the cracks and all of that. Right, got down to the final pour, and there were still bubbles. And, I took the torch and evaporated them, and there were more bubbles. And I evaporated those. And finally, it got to the point where the epoxy was set to the point that the bubbles weren't going to go away. So Liz says it's fine, it's beautiful. I look at it and I see the flaws, unfortunately. So I may sand it down and try again. I'm sorry?
An industrial trash bag and a vacuum cleaner will suck those bubbles right out as long as the epoxy is still liquid.
We also have a vacuum chamber that you can mix your resin up in, pull vacuum on it, pull the bubbles out.
Big enough That's just like 36
You would
inches.
do it to the resin itself, and then you pour it.
Oh, well, the bubbles were coming from the wood.
Oh,
Because I could see that they were right over the spots where there were cracks that I thought that I had sealed. So, yeah, but anyway, it does look pretty good though, and it was a big improvement over the tree stump.
Did you have any trouble keeping it sort of glass smooth when you sanded it?
I'm sorry. Keep,
Any trouble keeping the top really smooth and even?
no, when I finished it, you're talking about to pour the epoxy?
Yeah, I mean, it had to be kind of rough after you did the routing.
Oh yeah, I took a sander and sanded it.
But you didn't get any waves or anything?
Oh, no. My router jig leveled everything. It was parallel to the garage. Basically, what it was is parallel to the garage floor. Okay, and I made sure that the legs on the jig and everything, so when it cut exactly.
Talking about the sanding process. I've had trouble with big flat surfaces, and you sand them with a belt sander or a Randy Morgan sander, it won't be quite even, and you can see it when the light is.
It just took a light coat of sanding. I hardly had to do any sanding at all because the router flattened everything, and then all I had to do was just to knock off the tiny little edges. It worked out really well. Well, thank you.
All right, thank you. Next up, we have Jared, who's going to show us a bench and a shelf.
Hello? Are we good? No. There we go. Hey, so I've got a couple of projects this week to show off. One is this bench, and then on top I have a shelf. The shelf I kind of just made out of scraps. I had some stuff sitting around from, different things I'd picked up. And so I just kind of cut everything down to the right size. I put a French cleat on the back, and this bit here is cut on a 45-degree angle, so it mates up with another piece that I attached to the wall. It's all half-lap joinery, and then pocket screws hold it into the shelf itself. I figured I didn't want to do like a triangle base, and I wanted something to look a little bit more robust and, a little more angular and modern. So that's what I ended up with for the shelf. And then for the bench, I've been working through some designs from Christopher Schwartz's Anarchist Design Book, which is like a book on do-it-yourself, old-fashioned design. And so this is a three-legged bench that I've made out of ash. The legs I turned down with a hand plane. I just turned them into octagons, and they're tapered. And then the top is two pieces of inch-thick ash that I've laminated together with opposing grain. So it's really nice and sturdy and thick, and it's not coming apart anytime soon. It's all friction fit, but I can't remove those legs, and I think most people would have a hard time. So yeah, that's what I've got this week.
No glue at all?
The only glue I've used in that is to laminate the two boards together, but the legs are just friction fit. Oh yeah. I'll put the mic down. And that's what it looks like on top. So yeah. All right, thank you.
Very cool. I like the French cleat built into the back of that. That's a good idea. All right, next up is Rob, who's going to show us a LED light.
So last week, Toby, oh, this got turned off. Where's my, oh, it's on, it's just, we're missing, we need something to focus on, I think, right? There we go. Last week, Toby was talking about making a little model that he wanted to light up at the base, and he asked if I could make him a little LED that just turns on. And so I decided to make, there, we'll turn that off, right? A little circuit, but it's got a little 3D printed base. You can see that it's got, it's a AA battery sitting in there that just uses some wire at the front and the back and a little 3D printed spring clip. And when you first look at it, you think, okay, it's a battery and a switch that turns on. But the trick on this is it's actually running what's called a joule thief. So that light will go on, I think on a AA, it could last a couple of months easily on. And so the reason I did that is because I like to be difficult, actually, instead of just doing that. So this is the joule thief. This little dotted line piece is a single chip. Now, there are ways to make the joule thief with just transistors and things like that, but this is a nice little chip that you can buy. They're real cheap, the 5252. That's the chip there. You can see it's got 4 leads if it'll focus. Hello, there's focus. It's got 4 leads to it. The idea really behind this is it's a solar light. This would be a solar cell that will actually charge the battery. But for what Toby's purpose, he didn't need a solar cell thing, so I didn't connect that part of it. But this would actually charge the battery. It's got 1 inductor, that's the battery. It's got an LED, and that's pretty much it. So that's the only main component, and on that, I actually used a little surface, a teeny little surface mount one. Again, come on, thing, focus. You have to focus. Hello. It needs something to focus on. Where's our sign? It's still not going to focus on it, is it? Anyways, that's this little part right in here is a little surface mount inductor. There you go. You can kind of see it there. I use that because I have hundreds of those, and so it was easy to use. That inductor through this circuit will hit this thing with about 25 milliamps, which is why it's crazy bright. But I wanted to light up the inside of Toby's little model. But that's it. That's my little thing. He's going to have 2 LEDs, 1 under each foot. So the other LED that's sitting here, and I'll pass this around, isn't wired because I don't know how far apart the feet are until he finishes printing them out. So that was my little LED light. Yeah, if you were to look at that at high speed, that LED is actually flashing. So it's not actually on constant, it's just flashing so fast, you're not seeing it. And so what it'll do is the AA battery, it will actually run it down to almost 0 volts. It'll keep lighting the LED, even though the LED needs more power to light. The joule thief, because it's using an inductor, charging the inductor and then discharging the inductor through the LED, making it flash, the battery doesn't need as much power or voltage, so that battery can run down. A normal 1.5 volt battery like that could probably run down to 0.2 volts, and it would still be lighting that LED. So, but it's nice and easy with that little 5252 chip. Questions? All right.
Thank you, Rob. All right, next up we have Greenho, who's going to show us a bed.
Hey guys. So I told my wife that I wanted to make all the furniture in the house, so we basically don't have furniture in the house. So our mattress has been sitting on the floor for 4 years now because we're bad at adulting. And I guess I should show you the inspiration for this. So we really like mid-century modern furniture. So zoom out. So this is a mid-century modern splay leg bed. They're quite simple. The legs sit just in so you don't accidentally kick them and break your toes off when you walk around the corner trying to cut the fast corner. And then the headboard basically attaches straight onto it. And this was always a wonder to me, how does it actually attach and not snap the thing off when you lean against it? So that was one of the design issues I had when actually making this thing. So yes, you can buy these things, but the ones that are available, I've never seen one for sale that's original. So the ones that you can buy kind of look like this. They're like IKEA, Scandinavian style. You can get them for like $1,000, but they're all kind of just crap. So I always like to show where my lumber comes from. This one actually has kind of a cool story. I forgot to take a picture of the timber itself, but years ago I was doing a project for a natural gas pipeline. I was actually working on these timbers down here that go into the road surface that they make. They drive across them. They're quarter roads. They're these huge timbers that they bolt together. The important part of this is, for this job, I imported a bunch of mora wood from Brazil. Came up in a big shipping container, several thousand pounds of this stuff. And when it was all done, I had some extra. So I stole it, took it home with me. And I've been dragging it around the world with me every time I move since then. So anyway, that's what I chose to make this bed out of, thinking like that would be neat. It's kind of a cool looking wood. I don't know, it probably won't show up very well. But it's like a deep red color. It's an exotic hardwood, super, super dense, sinks in water, high silica content. So silica is what you make sandpaper out of. So you can imagine what it does to tools. What's neat on this stuff is you see how it has a lot of grain switching on it. So when you work with wood, you have to work in the correct direction. And this one changes direction every about 1/4 inch over the whole thing. So it's a real challenge to actually work with. So anyway, milling the stuff up was a chore. Let's see here. So started laying out the headboard. So this is the headboard. I don't know if I can get the colors to show up a little better. Will it? Zoom it in. So this is the headboard. And what you can see here is I have laid out a whole bunch of Dutchmen on the thing. So I had exactly one timber to make the whole bed out of. I could not get more of this stuff, nor would I want to. I never want to touch this stuff again. So I had to use a bunch of timbers that I would otherwise usually turn into firewood. So I have to put all these Dutchmen in inlays to actually hold some of the pieces together. So when those go in, you actually glue the thing up. Here's the headboard all glued up. So you can see I'm actually holding that piece together. So it was like 30-something inlays I had to do on that one. Then the base of it, I was going to do mortise and tenon joinery on this thing, but that was just a nightmare. This stuff's so hard to cut. So I ended up borrowing I forget what it's called, domino. So it's all like overlapping pieces with dominoes actually making the physical contact between the two. Between that and the legs, so I had to turn a whole bunch of legs for this. So there's one, there's 4 of them. And then because they're splayed, you have to cut the top. You have to cut the top like, you know, off axis slightly, so it actually fits together. And then when you actually install the legs into the corner pieces here, so these are cut and then wedged with ebony. So this is a friction fit, they hold themselves in. I also glued them, which is completely unnecessary. And then to actually put the thing together, you see it kind of goes up in and then it's bolted from underneath. So I have helicoils up into the rails and stiles on the board. And then I'm trying to figure out how to actually attach the headboard in real time. So what I did here is cut square mortise and tenons right through that end. And you can kind of see the underside of this. You can see the square holes coming up through it. I think you can see that. So cutting square holes through it, that's fun. And then actually starting to put the bed in. I finished it with antique oil finish, which is kind of nice. It's a mixture of oil and varnishes. Usually 3 coats get you through pretty quick. I had a bunch of extra sycamore left over from another project, so I clad the whole thing in sycamore. And then there's the bed all done. I think I have one more good picture of it. So, splay leg, mid-century modern bed. Oh. It also weighs 500 pounds.
All right, last up, we have Amos, who's going to show us some swatches.
A couple weeks ago, I showed some of the swatches that I had at the time, and I have a small update on that as far as just, in general, some more swatches that have been printed. But the main, yeah, let me, so, over by the 3D printing area, there's a board now that was salvaged from an old manual pick and place machine. It's a nice powder coated piece of steel, and each of these swatches have, right now, if I zoom in a little bit, they have just a label on the back, so you can tell what it is. And I have mostly, I'm slowly working through my collection of filament samples and printing them into these hexagon swatches. And the other thing that they do is they allow you to see kind of what their transparency is if you put some light behind them. And so anyway, the main reason I wanted to have an update tonight is because in the background, I'm also developing a website that will hold data that goes with all of these things. So what's the recommended printing temperature, and where can you buy it if you want that material. And we will put QR codes on the back of these, and you can scan them and find that material if you want it. And we're to the point now that momentarily there will be a link to the filament database project channel in the 3D printing channel. And that's where that project will live for the time being. I think we are to the point that other people can contribute these now and just write what's on the back or put a label on the back, and we'll fix it into the database once that part is ready to go. But that's basically the status of the project. The main motivation is this: you want swatches of filament for the same reason you want swatches of paint. If you're just shopping online and you see the colors, they're shot in inconsistent lighting conditions, and you can't really compare one color to another color. So for example, if I switch back to the light, got these three reds here, and two of them are very similar, but there is a difference, you know, between them on these two right here. And if you're trying to match an existing color to something, it's nice to be able to see it in person. Eventually, the database will allow you to do more things like sort by, you know, yield strength or elongation at break or impact strength, but that takes a lot more effort to get to that point. So initially, it's just going to be a, here's a cool color, where can I get that material kind of a thing. So, and some of them also, they shimmer a little bit, and it's hard to get that, again, online. You have to see things in person. So, yep. Any questions or, well, that's it. It will be on. It will be on the Mattermost channel. So yeah.
Have you created the channel yet, or?
The channel's created. I have posted the link to the 3D printing.
Okay. All right. Very cool. All right. That's the last one. Did anybody not sign up that wants to show off? Nope. Okay. So just a few announcements for tonight. We have some classes coming up. There's the Cutting Torch 101 class on Thursday at 6:30. These are all on our calendar, so if you want to join, go to the calendar and sign up. On Woodworking 101 on Saturday at 9 a.m., Inkscape 101 on Saturday at 10 a.m., and then a Laser 101 on Saturday at 1 p.m. So Saturday, lots of classes. Beyond this week, there's a Woodworking 101 coming on the 21st, an Inkscape for Laser class on the 21st. That's the first time for that one. That's going over extensions and things specifically for the laser to design. And then Billy's got a couple machining classes that are coming in 2 or 3 weeks, right? It's not on the calendar yet, but will be soon. So That's all the classes for the next coming month. We do need a volunteer to change the filter on the AC. Does anybody want to volunteer for that? Yep, we got one right here. And with that, let's just go have fun in the shop.